Hey guys, so I'm going to go over the day 5 notes, just adding in a couple more details, and just want to do this for some of you guys that learn a little bit better if I talk through everything. So today we're going to look at writing equations from ordered pairs. So consider, for the first part of the notes, consider a line that has a slope of 1/3 and contains the point 4, 6. If we want to write an equation for the line, we know the slope, but we still need to find the y-intercept. To find the y-intercept, substitute all of the known values into the equation and solve for b, right? Because b is our y-intercept. Okay, so equations from ordered pairs. From two ordered pairs, start by calculating the slope. This is not any sort of new information. We know that slope is y minus y over x minus x, and if we have two ordered pairs, we have our two y's and our two x's. Okay, then choose one of the ordered pairs, substitute the slope and the ordered pair into y equals mx plus b, and solve for b. Okay, so for these first few examples, we're going to write an equation in slope-intercept form given slope and a point on the line. So this one's a little bit easier because we don't have to solve for slope first. Okay, so let's say that the slope is 1/3 and then the point is 6/14. Okay, if this was in the form of y equals mx plus b, so y, I get y from my coordinate, which is xy. In this coordinate, x is 6, y is 14. So y is 14 equals m is slope, slope is given, x is 6, 6 is x in the coordinate, plus b. Now I just have a one variable equation that I can solve for. So I will simplify this. 1/3 times 6 is 2, so that simplifies to 14 equals 2 plus b. Take away 14 from both sides, and we get a y-intercept of 12. Okay, so for number 2, again, same idea. The y in the coordinate is negative 22, equals m, slope is given is negative 5, times x in the coordinate is 5, plus b. We simplify this equation to get negative 22 equals negative 25 plus b, because negative 5 times positive 5 is negative 25. Add 25 to both sides, and we get that b equals 3. Okay, so our equation goes back to y equals slope, which is negative 5, which was given, x plus b, which was 3. Now, one thing I want you to pay close attention to. We're given this information to get the equation of the whole line. So when you get the equation of the whole line, it needs to be y and x again, because the whole line is not negative 22 and 5 for x and y. That's just for one specific point on the line. But to have the equation for the whole line, it needs to be back in the general, which is y equals mx plus b with y and x still there. Same over here. So if you put negative 22 equals negative 5 times 5 plus 3, that is wrong. That is not an equation at all. That's just an expression. That's everything's already filled in. There's no variables missing. It can't be an equation if it doesn't have variables. So remember, to have a slope-intercept equation, what this is asking for, you need to keep the y and the x in the final form. Okay, the next two are the exact same process, so I'm not going to go over those. Okay, and now I'm going to look at notes part 2. Okay, so again, the only difference for these is that you calculate slope first. So for this, 5 minus 0 over 1 minus negative 4. Y minus y over x minus x is a slope of positive 1. Then at that point, you just use your slope and pick one of your points. If you use your slope and pick one of the points, you can use the exact same process as we showed you on page 1. Okay, so these are just more examples. Okay, and then down here, I do want to look at this word problem. At a local pizza shop, customers pay a set price for a large pizza plus an additional charge per topping. A large pizza with 2 toppings would cost $13.50, and a large pizza with 5 toppings would cost $15.75. I'm going to pause here because I have to make a second video, but stay tuned.